Okay, so those are booting up. That'll probably take a little while before we can log in. So while that's going, did we finish lab 23? And did you clean up and remove your Affinity off of your virtual machines? Okay. So that sounds good. So we're at lesson 5, using alarms. By the time I get done talking about using alarms, then the Vsphere server should be up and running. We should be able to go in and do the lab for alarms. So what do you think when you hear an alarm? Does somebody bump their car and open the door without turning the alarm off or something, and you just ignore it, right? Nobody looks. Somebody's actually carjacking the car. Yeah, so an alarm, something went wrong. Notification set. That way you don't have to just sit there and stare at a screen all day long. So that's pretty boring. Sean wants to play Nintendo games. Is that a Nintendo thing?
Yeah.
Okay, yeah, thought so. You don't want to sit and stare at a screen all day long. There's a bunch of predefined alarms in the system. One of them was predefined about our power supply not being redundant, and it kept throwing an error. So I just went in and disabled that individual alarm so it stopped going off, because I know that might as well throw the power supplies back in the system, because apparently taking the second power supply out doesn't alert the thing that it doesn't need 2 power supplies. It still throws a fit. So yes, you got lots of predefined alarms, and you can disable specific alarms, edit them, delete them, add new alarms and stuff to them if you need. You can even make a copy of an alarm. Probably it'd be better if you have a pre-built-in alarm, you want to make a change to it. I would click the alarm and add to make a copy of it, and not actually edit the original built-in alarm by itself. You normally don't want to ever change anything that was originally installed. You can create custom alarms. Just go to alarm, new alarm definition. So you can create alarms for different things: virtual machines, the host, clusters, data centers, data stores, distributed switches, import groups, and vCenter server. So once you select the object you want to create an alarm for, then you have to figure out what type of alarm. So you can do a conditional alarm. So it watches the condition of something happening, like is the VM snapshot, is it grown over 2 gig? Is the host using more than 90% of its memory? Stuff like that. And then you have event triggered alarms. Did a hard drive just fail? That's an event that happened. That's not something that might solve itself randomly. Licensing expiring. That's also an event. That's not something that's going to solve itself by itself later on. A network cable becoming unplugged. That's an event. So all of those you can be alerted to, or at least record a log on. So when you're defining alarm, here we got one, we got VM snapshot size. And then you got a little drop down that you can check, is it above or below or equal to or something like that. And then you specify a value. And then when that happens, you have a then. When the alarm is triggered, what do you want? They picked show a warning. You can add more stuff to it. You can show a warning and do something else. Maybe send an email. Slide that over. So you do a warning into the system and then send an email to somebody. You can also have a SMTP server running on your system that monitors for systems that are broadcasting warnings, alerts, and errors and stuff. They could come from switches, routers, Windows servers, VMware. So an SMTP server basically sees these broadcast packets and they can pick them up. And a lot of companies will have these servers that they'll have pre-recorded messages and stuff, and they can actually call you. It's depending on how much money your company's dumped into systems like that. Been hanging out with IT friends, and they get a phone call from their server telling them something's going on. Not hanging out with them as friends, because IT people don't have friends. They're too nerdy for that. They just get phone calls from servers and routers. You can also define alarm reset rules so that what happens when it resets to normal. And you can decide, do you want to be alerted if things go back to normal or not? Once the alarm is created, then you can decide, do you want to enable it or not at the end? And you can do the little slider to enable the alarm. So alarms are not too hard. If you're going to send an email, you must define an email server and the email address that is sending it. You'd also have to go to that email server and probably configure that it's going to accept emails from a particular IP address without authentication. Because if it's coming from this server, said, hey, I need you to forward this email to the admin from this address. It's also going to have a source address, and you don't see a way here for an authentication. So you'd have to modify your configurations for that. And that brings us into lab 24. You create a virtual machine alarm to monitor conditions. You'll trigger it, and then you'll disable the alarm. Let's see if our vCenters are available now. It appears that my long, monotone, boring talking has given them time to boot up. And only Brian fell asleep. It's like, what? I'm joking.
Mine isn't connecting.
What was that?
Mine isn't connecting.
Mine is just spinning too.
Mine just says the site can't be reached.
Interesting. So mine went to the page. Let's Why is yours not working? Are you inside your virtual machine? Your Hyper-V machine?
Yeah,
Is it maximized? It doesn't look like you're in your inside your Hyper-V machine. Yeah, you're not inside your Hyper-V machine. That's why it's not finding it. Launch Hyper-V in your Vsphere class. That's what's going on. You're connected to a different, the host machines are connected to a different DNS server than the Hyper-V. Okay, so I'm going to check out alarm 24, not alarm 20. We're probably on page about 90. 88. So using alarms, so what do we do here? Log into our vCenter server. Looks like you're using one of your virtual machines, doesn't matter which one. Just make sure that you've got Affinity removed. That was one of the last steps in the lab 23 that you disabled and got rid of, deleted the entry for Affinity. So do that before you start them if you didn't clear Affinity out from the previous lab. So you have to start up the virtual machine, create a new alarm. You run your CPU busy just like you did in the last two labs. Acknowledge alarms. That's going to be a pretty easy one to do. And it looks like you're just messing with the same virtual machine all the way throughout. Okay, so as you're going through that lab, I think there's one thing that this section didn't discuss, but it is something that if you got to do maintenance. So see, we have two servers here going. And if you have alarms set up and you're going to do maintenance on a server, maybe you need to migrate all the stuff off of it to add RAM to it, change out RAM, you're going to do something with it. If you're going to be making changes that might throw alarms, and especially if your system calls IT people, and you're like, go make a change, and all of a sudden it calls all the IT people that something's going on, and you can right click on a system, you can go to alarms, and you can temporarily disable all alarm actions on a particular host before you go make changes to it. So that's a little warning, especially if you're working late at nights, because you've got the job of having to work when nobody's at the university working and you're at 10, 11 o'clock at night fixing things. You don't want to accidentally have the system call all the IT people at 11 o'clock at night. Most of them are old and like to sleep, so. Oh, they're laughing at that. It's like, yes, there's some old people there. For those that work in IT. Of course, you'd want to re-enable them later on, but that is something I think that is on my test, is that if you're going to make some changes and you don't want alarms firing off, what would you do? Right click, alarms, disable alarms. Disable alarm actions. It's pretty easy to do. Okay, lab 24. So we finished up lab 24 and finished up module 8. There's won't be a test on Thursday, but we'll see Thursday when that test is going to be moved to. Okay, so module 9 here, vSphere clusters. So a cluster, we don't quite have a cluster yet. We have a vCenter server with 2 virtual or 2 hypervisors in it, but a cluster basically links blade servers together and allows resources to be automated. So we've been monitoring CPU utilization, RAM utilization, stuff like that. And a cluster helps with automation process, basically stating that the servers that are in the cluster have similar hardware capabilities and that things like vMotion, storage motion should work across the cluster. It allows things such as high availability and fault tolerance. Both of those deal with getting the virtual machine back up and running, either with little downtime or a 0 downtime in the event of a hardware failure. So depending on which one that you have configured will be depending on if you have a few minutes of downtime versus 0 downtime. Here's some examples of our little sample company here, business critical apps. They say need to have a 4.9 uptime. That's equivalent to only 52 minutes down a year. Non-critical apps, 99% uptime. You're going to be down at least 3.65 days per year. Some companies strive for a 5.9 uptime. That's like 5 minutes a year. That's a little bit insane. Windows patches and stuff like that normally keep stuff down more than 5 minutes. Although there's Linux machines now that you can hot patch the kernel and things to help alleviate downtimes. So vSphere cluster overview. You cluster, you create a data center, and then under the data center, you create clusters and you put virtual machines, or you put the hypervisor servers, ESXi host inside the clusters. So looking here, it looks like we've got a system that's actually got 2 vCenter servers running, the data center for each one, and they've got 2 or 3 clusters of ESXi hosts. This must be a pretty big outfit if they got something like that. A cluster can contain up to 64 ESXi hosts. Basically, you can have 64 blades that you can load balance, set up fault tolerance style between those 64 systems. Creating a cluster is pretty easy. You create a cluster and you give it a name. Then once the cluster is created, you have a couple of options that you can enable depending on the version of vSphere that you're running. So everybody's probably running 6.7 or 7.0. So you can turn on distributed resource scheduler. You can turn on high availability, and you can also enable virtual SAN if you would want. And you can specify the ESX version that can be added into the cluster. So they have a quick starter. It'll let you go through and ask you several step-by-step wizard. Makes it a little bit easier to enable the cluster. They didn't have a wizard in the olden days. In the olden days, you created a cluster and then you had to go in and edit settings and go individually, click through all the settings and flip what that you wanted. to configure. And now they've got a quick starter that you can work through. So the quick starter lets you do a lot of tasks, a little bit more automated. And they've got a whole documentation on it, since quick starter is kind of a new thing that you can click and read about. You can also just configure the cluster manually. Once it's started, you don't have to go to the quick starter. You can click on the cluster object and just go to configure, and you have a whole host of sections where you can go through, and like the old days. Except there's a few more options now. They've expanded the capability of clusters. Add a host to a cluster. Really hard. You drag and drop it into the cluster. And they are this is wrong. Of course, they're graphics. They always screw up on the graphics. What is wrong right here? Can anybody see what's wrong with the graphic? Where is the arrow pointing? It's pointing to a data center. It's not pointing to the cluster. The cluster looks like 3 servers stacked together. See down here? It says drag it to the cluster, and they're dragging it to the data center. Now the arrow should be pointing down here at compute, where that you're dragging it to the cluster. So there's I don't know who did the slide, but they drew the arrow wrong. Just an FYI, just to let you know, if you're reading through here, the arrow is pointing to the wrong spot. That is not a cluster. Once you have a cluster, it's kind of interesting to look at the cluster, because the cluster over here, the CPU, is the total CPU processing power. So all of the cores in every blade that you have is added up. So the amount of gigahertz can look kind of crazy that it shows is available. Also with the RAM and stuff too, can get quite massive, because if you have 64 systems with, half a terabyte of RAM in each one of them, it would show up, 64 times, you'd have 32 terabytes of RAM show up. You can monitor the cluster resource utilization too. What percentage of the available hardware that you have is being utilized. So you're not looking at individual virtual machines. You're not looking at individual ESXi hosts. That's what we've been doing this whole time, is looking at just one server or one virtual machine. And now you're looking at the grouping of them, and you can monitor them. So that's pretty cool. Distributed resource scheduler is a feature that is available with the cluster. What is its purpose? Its purpose is to load balance the physical servers that are running inside the cluster. So it uses vMotion. And if you have it set up fully automated, it will automatically migrate virtual machines from one physical server to the next, so that the virtual machines aren't overloading one system. If it ever sees an overload on the system, it'll spread the workload out to the other servers that aren't doing much. Same thing with RAM and stuff too. So it's really cool. It's got several methods of doing DRS. If you don't like your machines automatically swapping around in the middle of the day and you losing what actual physical server they're on, then you can put it in different modes. Instead of fully automated, you can make it to where that it will make suggestions to you or it'll fully automate. Like when you start a machine up, it'll automatically choose the server to boot it up on. Or it can be fully manual. When you start up, it will make recommendations to go, hey, you should probably start it up over on this system. Where do you want to? So it's got several methods of control so that you don't lose control of your network if you want to be the almighty admin and control everything yourself and spend all your time tracking things. Some other cool things, DRS, there's a power management DRS that you can enable. That's really cool. So instead of actually working to keep everything spread out, DRS can integrate with the power management DRS function, and it can monitor the machines and all the servers and determine that if you've got enough spare capacity that it can consolidate machines onto fewer systems and still have plenty of resources to run everything, it will power off the blades that aren't needed. That could save lots of money. Also, think of like nighttime. As workload backs off during certain hours of the day, it might be able to consolidate and power machines down. If workload picks up, the power management feature can also turn on the servers and then migrate the virtual machines out as workload increases. So that can save a lot of money. Think about it. If you turn off a system that's, pulling 300 watts, that's some money you're out to pay the electric company to run that. Also, think about the air conditioner that has to run to cool that 300 watts. So you've got a double electric bill there if you're not considering. So if you're able to turn off a single server, you're not only saving its electricity, but you're also saving the money spent on cooling. And you're helping the environment so that we don't get flooded by all the ice caps melting. They've been saying forever. So moving on, let's look at Drs Score. So basically looks at contention and stuff, does the scoring and makes recommendations. Pretty much doing a standard deviation of, what each machine is running, and if it gets out of balance, it will migrate. It'll look and see if it can balance workload by moving virtual machines. You can also look at the score of each individual virtual machine to see what type of contention or workload it's needing to put on. So as the score says, as the score gets closer to 0, there's more contention, and that would mean that the DRS would try to figure out, the virtual machine be moved somewhere else, because there's more contention between virtual machines for a single piece of hardware, and we might need to migrate it off. So we have a 24% score. That's getting kind of close to 0. It's got a recommendation that says, hey, we've got a couple of VMs here just getting down to the 0 to 20 range. They're fighting each other. It probably is recommending to move one of these virtual machines to another server. So if these two machines that are fighting each other, they're in this band right here, can be alleviated and not fight with each other too much. What's looked at to come up with that score? CPU, active and used, readiness value, memory, swapping, and ballooning are all looked to see if any type of contention is going, to try to figure out where to rate particular machines. And as we learned in previous chapter about monitoring, you can use charts and stuff and watch the chart of your cluster and watch the scoring charts go across. Here we have 100%. There's no contention. There's 10 virtual machines. They're all spread out. Notice there's no recommendations on this one. These are different from older vCenter, vSphere products with 7.0. The scoring is different. In the past, they had a level and they had like a little bubble. Has anybody ever used a level before? Hang picture frames for your mom. You have to level it. Stuff like that. So it always had a level before, but now they've got this new scoring mechanism with banding, so you can see what virtual machines are causing contention. It's going to be really hard for us probably to create a contention on our system. We're likely going to have to vmotion all the virtual machines from over to one host, turn them all on, and probably run CPU busy on all of them. And with as fast as these new systems are, I don't know if that'll be enough to cause enough contention for DRS to decide that, hey, we need to move things across. We'll see what the lab has us do. They may have a little workaround for it. But here's the automation levels. You've got manually, partially automated, and fully automated. So fully automated virtual machines are automatically migrating from host to host. Manually, when you power it on, you're given a recommendation of what to boot the virtual machine on. You also have an area that you can go to, and it will give recommendations that virtual machines need to be moved. It will not do it for you, though. You'll actually have to manually tell it to migrate the machines or right-click migrate machines yourself. Partially automated. When you power on a virtual machine, it places it on the best host that it can determine. It doesn't ask you, it just automatically places the virtual machine on the best host that it determines. And it does not automatically move machines. It'll be similar to manual in that case. It will give you a recommendation list and go, hey, you're out of balance. If these machines are moved around, it would be better. And then you can apply the recommendations or not. So you've got those three different types. Something else on this page, you've got a migration threshold here that you can set. You can get really aggressive and make it like constantly monitor, and even if there's just a little bit of contention, try to like migrate the machines to alleviate any contention. But if you get too aggressive, you're using network and resource power to vmotion the machines across. So you may slow down your network. You may not get any improvement because you're migrating stuff all day long, trying to load balance things out. So be careful about getting too aggressive. Probably right in the middle is better to a little bit conservative. You don't want to constantly move the machines around. That does take resources. So careful with your aggression. You might get thrown in jail if you're too aggressive with a cop when he pulls you over, or get shot at. One of the things. This is going to be on YouTube. This is terrible. Terrible, terrible. Maybe nobody will hear this outside of class. They'll be asleep by this time in the video anyway. The migration threshold determines how aggressively DRS. So yeah, that right there. You have all these different recommendation levels. Like I said, I would, in a production environment, level 3 or level 2 would probably be better to run at. Level 4 and 5, you would be probably literally slowing down your network because you're migrating too much. And you're doing the opposite of what you're wanting it to actually accomplish. predictive DRS can integrate with something called vRealize Operations Manager, and they can try to predict failure and predict future demand loads. Is there a failure prediction? No, not a failure prediction. So vRealize Operations Manager is kind of like an AI system. It's an appliance that you deploy out, and it monitors all the log files, and it uses all the metrics. Basically, it does its own baselining automatically for you. And after a certain amount of weeks or so that it's monitoring, or as the weeks go on anyway, it starts getting a history of which virtual machines spike in CPU or contention. And it can feed that information into DRS so that if it knows that, 1 o'clock in the morning, the backups kick on and all, for some reason, it may not know about backups, but it knows from 1 o'clock to 3 o'clock in the morning that there's a whole bunch of resources needing to utilize. So it can before that happens, automatically migrate virtual machines out that it's watched, especially the ones that peak during that time, so that they're sitting there ready for them to have full power of whatever they're doing. So that's what predictive DRS, and you need vRealize operation active to do that. Swap files, normally they are kept in the same folder, but you can specify in the cluster that swap files are kept on an alternate data store. So if you have an SSD, like Intel Optane memory or something that you've got in a NAS somewhere, and you're wanting to keep the swap files in that location, you can configure that. But as I told you before, if you're swapping out, you need more RAM. You don't need a data center where that you're having to utilize swap. So add more RAM, because people are not going to be happy if you're swapping. And spending money on expensive SSDs versus just buying more RAM is, I don't understand the logic behind that. Downloadmoreram.com. Yep. Craziness. Did we do that in class? Downloadmoreram.com. I've done that in the past. We got to have a little bit of break. I've done that in the past. Download more RAM. So just downloadmoreram.com. Download more RAM. It's great stuff. 64 gigs, not enough. Let's download some RAM. Let's see, how much more RAM do you want? Please select the amount of RAM you'd like to download. One cannot simply download too much RAM. So we'll go and select this plan right here. Your RAM downloads will begin shortly. Download, here we go, initializing. We're on the interwebs, retrieving all the RAM. Almost there. Yay, we're done. We downloaded 32 gig more RAM. Click here for more info. Look at this, you get rickrolled. Okay. Anybody ever been rickrolled before? Bronze back there, yes. Some great stuff. That means like, you're an idiot if you get rickrolled. So if you ever click the link and get to that, now you know that you've just been called an idiot. Okay, great stuff. Something with the problem of doing a fully automated DRS you can run into is the automation process can move virtual machines onto the same server or separate them when they should be on the same server. So you got the problem of machines being migrated to load balance and they're all thrown onto the same blade when they are actually designed to be separate. Then you have problems where you have virtual machines that need to be together, but DRS accidentally decides that they need to be separated out for performance reasons. So Active Directory domain controllers, best practice from Microsoft is to have them running on separate physical machines in case a physical server goes down. There's still another Active Directory server up and going. It's a clustered environment that uses SQL and it auto clusters itself, multi-master replication going on. So you would not want Active Directory domain controllers that are being virtualized and to be automatically migrated to this all to the same host. That would be bad. Vsphere allows you to create rules. Here's a rule for separate virtual machines. So you create a rule, you give it a name, maybe like Active Directory domain controllers or something like that. You enable the rule and you add all of your Active Directory domain controllers into the rule. So that rule basically states these servers, if at all possible, need to be on separate machines. Don't migrate them. So if there's a DRS recommendation like, hey, if I'll put this server over here, it would help load balance. But if that moves it to a server that's also a domain controller, like, nope, can't do that. This rule blocks it. You have another rule. Keep virtual machines together. And then there's a couple more here that looks like that they've added. So keep virtual machines together. You add the virtual machines that need to be running on the same host. Why would you need virtual machines to run on the same host? There's something called a multi-tiered application. Canvas is a multi-tiered application, meaning that it's got the application server, the web server, that's interacting with your browser and displaying the information. And then it's got database server that actually stores a lot of the information. And then it probably also has a file server that stores the blob information, meaning the actual, when you submit your assignments and you're submitting PDFs and movies and Word documents and stuff, it probably goes and just records a link in the database to a file storage location. So that's being stored. So that's called a multi-tiered application. So you have maybe a Windows machine running the web app and a HP Unix machine running the Oracle database server or IBM DB2 or something. And those two machines need to communicate with each other because you look at your grades. You want the information out of the database about how bad did you do on your last test pop onto the screen. So you want those on the same server so they can communicate quickly. That's where a keep virtual machines together is a multi-tiered application that they rely on more than one virtual machine to communicate. So they got to share communications between each other. And then virtual machines to be separated out are any machine that has a high availability or fault tolerance rule style thing. Anything that you're clustering, web servers, Active Directory domain controllers, a database cluster, anything like that, that the cluster is to keep the system up in case of a single point of failure. You want those to be separate. So these rules are very important to implement if you implement a DRS. If two rules conflict, it just basically nullifies them. And then a couple more rules here. It looks like virtual machine to virtual machine would be the same thing as keep virtual machines together. Virtual machines to host would recommend that certain virtual machines are always on a particular host and not migrated. To help with some stuff, you can add groups. You can create a group of hosts, and you can create groups of virtual machines, and you can apply rules saying that this group of virtual machines needs to run on this group of hosts. That's helpful for hosting environments and service level agreements, also abbreviated as SLAs. Some of you that are working with Network Services Group may have heard of SLA, service level agreement stuff. So depending on who that you're hosting with, you also took Intro to Security, Security Plus. So you've likely, if you've not heard of SLA, well, you have in the past and just have forgotten it by now. But service level agreements. So if you're going to host virtual machines for the Jacksonville Police Department, and you're going to host virtual machines for the BB Public School, and you're going to host virtual machines for Simple Simon's Pizza, well, you're likely going to have a security issue with the police department. They'll actually probably have more federal regulations and stuff for security of the machines. So you might have to create a group of hosts just for the Jacksonville Police Department and a group of resources and stuff like data stores and things like that, that their virtual machines are only allowed to run on those systems. And then the ones you're open for Simple Simons need to be only on another set of hosts. Because if you allow Simple Simon's Pizza virtual machines or Windows Server running, and it's somehow running on the same host that the Jacksonville Police Department is, there's always a chance that somebody's hacked Simple Simon's and that there is a bug in the Vsphere environment somewhere that allows somebody to be hacked into that Windows machine and figure out how to jump out of the virtual machine into other virtual machines, actually access the Vsphere environment, and then they could get into the police department's information that way. It doesn't matter if it's Hyper-V, Citrix, VMware, it's software. There's always that possibility of a bug happening. So these here rules are our mitigation point on that on security that you can use. And that's one of their main purposes, is for service level agreements and security. And if you're a hosting firm, this is something that you would probably need to study more in detail. If you go work for the BB Public School and you're running virtualization over there, these rules wouldn't really matter because you're all the same entity. So you're safe. Same thing here at the public school. You're working for IT department, you're setting up stuff. We don't have rules like this because all our stuff is ours. But yeah, for hosting firms, this is a capability in there. And some of you are working for hosting firms or interning there, or may go to work there. You have Affinity Rules 2. That basically goes along with those groups. Affinity means that you defined a group of virtual machines need to run on a particular group of servers, and then anti-affinity. Basically, they should be kept away, saying that you should not run on a particular set of hosts. And then there's must and should. What's the difference between must and should? Recommended versus required. Correct. So let's take a break. Just think about must and should. When we come back from break, we'll use the same scenario about the police department and simple Simons on what that we should choose, a must or a should type rule. So I forgot to resume recording before, but lab 25 is where we're moving into implementing the vSphere DRS cluster. And if your partners are not here, you're likely going to go ahead and have to use their virtual machines too to do a load imbalance. Let's look through here and come up with task 1. So we created a vSphere DRS cluster to ensure that we've got a resource requirement. So you're going to log in and we're going to have one person create a new cluster. Who's that person going to be in y'all's group? VC1, who's going to do it? Okay, so group 1, it looks like Jared's doing that one. VC3. Who's doing it in VC3? Aaron? Aaron says he's doing it for VC3. Okay, VC5. We've got, well, Riley and Haley's not here, so who else is with 5? That'd be 6, James, Heifel, and Andrew. So James Heifel can do it. Let me see, and then we get into 7. Let's let Brian do 7. Okay, so you're basically right click, do a new cluster, and the name. Yeah, we can go and do the ICM-compute 01. And Jared, don't go next on yours yet. I want to show your screen. You're clicking the VRS toggle buttons on as you're going through. So this is what everybody is seeing. We'll let a few seconds here for that to go. So they've typed in, right-clicked new cluster, gave it a name. We've done the little slider. Hey, turn on DRS. And we've not talked about high availability or other stuff later, so it's saying leave those off, leaving up the default. And you are now clicking OK on that. So once you click OK, everybody should be able to see in your host and clusters view at the bottom or somewhere, you should be able to see the ICM-compute 01 has been created. So now, let's see, I think this is still Jared for task 2, yeah, then Brian, Aaron, James. So let's look at task 2. You're going to click on the ICM, click on the configuration tab, and we're going to look, and we're going to see that we have a vSphere DRS section. So let's look at that. So as he's got it clicked, and clicked on configuration, at the very top of the list, there'll be vSphere DRS. And that gives you this option right here. So here's all the different stuff. Right now, it looks like it's set to fully automated, but the instruction says go ahead and click edit. And step 3 As you see, go and hit the drop down there, Jared, so you can see it a little bit better than we could on in the book here. So you have manually, partially automated, fully automated. I think it was by default set at fully automated. So we changed it to manual. And we want the migration threshold slider to be aggressive. So predictive DRS is not checked because we don't have vRealize operations. And the virtual machine automation is enabled. We've got to click to manual. There's some other tabs here that you can look through before you hit OK. If you have hit OK, you can go back to edit, but we can go and look at additional options. And you can look at being able to overcommit, scalable shares. Go click on power management. So this power management is one thing I talked about in this section. They didn't actually have it anywhere in the curriculum, but power management is there, and I've done this before. We've turned it on and enabled it, and we've set it to automatic and aggressive so that it monitors the system, and over the weekend it would shut down one of the blade servers. It's pretty cool. And we come back on a Tuesday and we'd run CPU busy on all the machines, and it would power one back up and start migrating things across. So we might do that if we have enough time. The snow apocalypse we had may prevent us from being able to do that. Go ahead and click on the advanced options now. Just look what's under there. So stay curious on these, and you can add advanced parameters if you need to, but just go and hit OK. If anybody wants to look closer at that dialog box, you could go into the DRS and click edit. Just don't make any changes if anybody's wanting to look closer at that. So now we move on. Now we need some different people. Task 3, adding the ESX host to the cluster. It's pretty easy, and before we do that, I want to show something else, because I don't think you have the option of doing it. So we'll make Jared do it again. So if you're looking on the cluster, everybody can actually look at the cluster, click on it, and click on the configuration tab. And then over here on the left side, we have something called VMware EVC, VMware Enhanced vMotion Capability. Go ahead and click on that and click on edit. Everybody should be able to do that. So with this brought up, it's disabled by default, but Enhanced vMotion is a way to mask off features of new processors so that your virtual machines can be running at the oldest CPU level of any of your blade systems. That will allow for greatest flexibility in vMotioning systems. If we buy a 10th gen HP and add it into our cluster, the virtual machines that were started up on it would not be able to migrate to ESX 1 or 2 in this case, because they would be trying to use new instruction sets on the 10th gen HP server, and we're running 8th gen. And likely I'm sure the CPU Intel's got different version. So if you click enable for AMD host, go ahead and click the radio button, and everybody can do this. We're not actually going to hit OK, but you can hit the drop down there for the generations. And I want to see, we have all of the Alterons, and then we got Zen. So Zen would be moving into the EPYC processors, the EPYC 1st gen and EPYC 2. So they've got those in there. It'd be Zen 2 for EPYC, probably EPYC 2, I would think. So whichever one is your oldest running AMD server, you would click it. And then any like Epic chips that were started up, it would hide their new functionality. And then you could migrate. Really cool. Go ahead and click on AMD now, or Intel. So with Intel, you go ahead and drop it down. You have all of the different models in the list. So what should you select? Interesting. Let's go ahead and I'll bring it up on my page. So that's by chipset. Microsoft's generation of processors go by the chipset, and that's how that they've labeled them. So we don't see this model in that list. We don't see, hey, limited to an E5 2620 chip. So how do you figure out what to do? Well, if you go to just browse the model chip that you're running, and you go look it up, the code name is Sandy Bridge. That's how I'd figure out that these are our oldest servers that we've got running. So I could pick Sandy Bridge and go ahead, and the person that originally edited the cluster, so that would be Jared. Go ahead and click Sandy Bridge, and everybody else can click cancel. But if you're the one that started, go ahead and click OK on this. So I'm showing this because you need to enable this before you put host inside of it. If hosts are already inside of it, it can be difficult to enable that feature. So that's not part of the curriculum or any part of the lab, but it's a cool little thing that's really cool if you're setting up a cluster for the first time. That's one of the major features of it, that you can enable enhanced vMotion. And even if you bought new servers and you're setting up for the first time, go ahead and set the level at all of your new servers level, like Sandy Bridge here. We just set that. So 5 years from now, we buy new systems and throw them into the mix, we're able to migrate back and forth easily, because we're still masking them off. Once you get all your old servers out of the way, you can bump the level up. Okay. At this point in time, we need to go with the other people in the group. So let's look at task 3, and we'll stop at task 3. Task 3 is simply dragging the ESXi host to the cluster. So Bethany, you would be dragging ESX1 into the cluster. And then either Sean or McGuire be dragging 2 into the cluster. Matthew York would be dragging 4 into the cluster. I guess Alex, you'd be dragging 3 into the cluster. And then I don't think Andrew's trying to connect. There's not a VC6, it's VC5, Andrew. We deleted VC6 a while back. So Andrew, you'll be dragging ESX5, and James Heifel, since everybody's missing in 5, you'll be dragging your ESX6 into the cluster. So you actually get to do that step. So it should just be a drag and drop. And keeping the defaults. Just drag and drop, keep the defaults. Okay, so we're down here to Brian. I think you're the only one that I see remoted in to your group. So it looks like you're going to be charged with dragging all of them into the cluster. So yeah, then just click OK. What's it say? Well, darn that. Go ahead and just shut down those VMs. Just right click and shut them down. You can aggressively, you can power off, make it fast. When you power them off, then they should be able to drag in. We'll worry about starting those up later. So now if you drag them, see if it works. Yep. Okay, cool. So now if you expand out your cluster, we can actually, I think at this point, go ahead and right click the lab servers folder because there's nothing in lab servers anymore. So you can go ahead and remove that from inventory. There's no more lab servers. And I don't believe that we'll ever get rid of our cluster for the rest of it. So at the very bottom, when you right click lab servers there, Brian, yeah, it says remove. There you go. Of course, only one person can do that once they're dragged in, but fight amongst your group who does that. Notice the virtual machines are no longer associated with the host because when DRS is on, they can just automatically flow them back and forth. So there's no longer an association. I'm trying to remember if we boot them up, if it puts them under there or not. I don't think it does, but we'll play with that next week. Somebody make note, we're on task 4. Everybody else is get dragged in. You refresh your page, see if your partner's got it done. So make note, we need a task 4. We'll have to work together. To get everything going. Yes. Yep. This is when the VM and templates view becomes more of a place to look at and manage stuff. Okay. Next week. Not next week, Thursday. I don't know what day it is. I'll see y'all Thursday. We'll do that. Yay. I was already starting to think we lost the whole week.